let's look at the section 8.6, solving rational equations, on your page 29. So what we have been doing? Rational equations, right? So what we did was what? Learning the basic skills: add, subtract, multiply, and divide for the rational equations, right? Polynomials in fraction forms. So first we learn the basic skills, just like anything in your basic algebra, right? Then what do? Then we will solve equations, right? After we do that, usually we do what? Solve problems. That's the approach, what we have been learning, right? So we did what? Add, subtract, multiply, divide rational equations. Now we are going to solve equations, right? So the way we do it, then we will write down the steps later. So let's see some examples first. So if we have this one, right, for your example 1, we will call it rational equation, right? Then how do we solve it? So we want to make it simpler first. There are many approaches, okay? But we just stick one approach, say make everything simpler, then try to resolve it that way. So if we make two fractions simpler, it means what? Add them together with LCD, right? So this one would be what? Times by 3x. This one would be times by 2, 16, right? So we have what? 1/6. Then we make one fraction, then becomes this way. Both sides are simple as it can be. Then what should we do? Okay, just like if you have 3/7, then x over 7. What do you think your x will be? By comparison, you can see x should be 3, right? You can ignore the 7. So if both sides are simplest form you can have. So this one you can just ignore 6, right? Same thing as you multiply by 6 on each side, then you cancel out your 6. Or you can just directly cancel out the 6 for this case, right? If you have same denominators, you can just make what? The numerator the same, right? Now it becomes what? A linear equation. So we do that, right? 3x equals -15. So x divided by 3 will be -5, right? Then you check, you plug back in, and you can check the answer. Okay, so that's the idea. That's the one approach we can use. So let's write down the thinking. You will make one fraction on each side, right? This way you can compare. So by doing what? Okay, you can do, okay, we just write here. By writing what? Standard and prime forms, right? Because you have to make one single fraction on each side. Then when we add the rational expressions, we usually write it in standard and prime forms. Then we will write it in what? In LCD form, right? For each side. Then we will just add and subtract as we did before to make one fraction, right? Then after that, we will do what? We can just eliminate the denominators, right? But you have to be careful, okay? Note the restriction. Then we'll talk about what are those. Then what do? We will solve for x, right? Then we will check. That will be your thinking process. There are many ways, but this will be one of the easiest way we can do, right? Let's take a look at the second example. We have t minus 4 over 2 minus t minus 3 over 9 equals 5 over 18. So, writing one fraction on each side. So this one, but you have to find the LCD for all of them, right? To be compatible for each side. So 2, 9, 18, you will use what? 18, right? So this one, t minus 4, will multiply by what? From 2 to 18, you will multiply by 9, right? And this one, you will multiply by what? 2. 2 times t minus 3, right? And this one is fine. It's 5. Then we are going to make a single fraction, right? This way. Writing in LCD form, right? Then we combine the numerators, right? Then since they are the same denominator and 18 is 18, there is no restriction yet. So we can just leave them alone and get rid of it. Then we will write this way. So from the beginning, you have fractions. Now you don't, right? Then you can just solve it. Then you can decide, is this a linear or quadratic? So let's take a look. So for this one, it's linear. So we just combine the like terms and take care of your signs as well, right? By distribute them. So by distributing them, so then 9 minus 70 minus 30 equals 5, right? Then it's a linear equation. You know how to solve it. Then 70 equals what? 35. So divided by 7. So your t is what? 5. Then you check. Right? Okay, look at the next one. You have 3 minus 6 over x equals x plus what? 8. So one side with a fraction, one side doesn't. Okay, so we have fraction now with variable in the denominator, right? So when you have a variable in the denominator, you have situation with what? Restrictions. Because we say what? The denominator cannot be 0, right? So you know you are going to find the x is some kind of numbers, except what? You cannot use. The denominator is 0, except, 0, right? X cannot be 0. So that's your restrictions. So you better write it down before you start everything so you don't forget, right? Then we want to make a single fraction on this side. So this is the denominator is 1, right? So what's your LCD for all of them? That would be what? X. So you write in prime form with LCD, right? For this one, you will write all the x, right? So from 1 to x, you multiply by x, right? So that would be 3x. This one is the same. This one you will multiply by x, right? So that would be x squared. This one multiplied by x, that would be what? 8x. So you write in a single fraction on both sides. So this one will be 3x minus 6. This one would be what? X squared plus 8x. Is that right? Then we say, then eliminate the denominators. We can just eliminate the x because we have restrictions, right? But we eliminated, that means x cannot be 0 at this point. Then after this, what do we have? 3x minus 6 equals x squared plus 8x. So what kind of equations we have, which is not in standard form yet, right? But x is to the second power, that would be what? A quadratic equation. And we'll move everything to the right hand side because x squared is over there. To make a leading coefficient, it's positive, it's easier. Is that right? So now we have quadratic equation. Before we have what? Linear equation. So how do we solve a quadratic equation? 3 terms, trinomial. So we use what? AC method. But the leading coefficient is 1. We can just do the x and find the 2 numbers. Multiply together is what? 6. Add together is what? 5. That would be 3 and 2. Is that right? Then we solve it, so we can have what? X plus 3 equals 0, or what? X plus 2 equals 0. So this one, x is what? Negative 3, or x is negative 2, right? Then you want to make sure it's okay to circle it. Can we do negative 3? Yes, because it's not 0. Can we do x negative 2? Yes. No, negative 2. Or you can check back to the original equation to find out if it's okay. Okay? So, or you can just check against your restriction. If you do everything right, you can just make sure it's okay. Either way, right? So what we have been doing is what? Solving rational equations. So for the purpose of this class, from the fractions, right, rational equations, the idea is what? Change it, become simpler to the things we know of. One is what? Linear equations. One is what? Possibly here. Quadratic equation, right? So that's how we solve rational equations. Okay? So you wanted to make sure each side is a single fractions by doing all the basic skills you have, right? Then you can eliminate your denominators with restrictions noted, right? Then you can solve x. Either this one is what? Either for your class, either a linear equation or a what? Quadratic equation, right? So let's look another example. We are on the 3, this one is 4. So 4x over x squared plus x and 30 minus 30 plus what? 2 over x minus 5 equals what? 1x minus 6. Right? So we want to make each side as simple as possible. Right? To be a single fraction on each side. At the same time, we want to have both sides with same LCD. So we have to find the LCD first. To be able to find the LCD, we need to do the primes, right? So we can compare all the denominators to have LCD. So this one would be x plus 6, x minus 5. Would that work? Multiply together, negative 30, add together, positive 1. Right? This is x minus 5. That's prime, so put a parenthesis around. So then x plus 6 is a prime, put the parenthesis around, right? Then what is your, this is in prime form, right? Then we will write it in what? LCD forms for all of them. What do you think your LCD would be? X plus 6, x minus 5, right? To cover all of them, x plus 6, x minus 5, x plus 6, x minus 5, right? Then this is the same. This one, this is extra. This one, this is extra. Right? So this one, it's the same thing. And this is extra. You have to multiply both for the numerator and the denominator. Then there was 2 before. Then this one, we need to multiply by x minus 5, right? So that's what we have. Do we have all these same LCD? Right? Then we can eliminate all the denominators. We combine the top. That would be 4x plus what? X plus 6 times 2 equals 1 times x minus 5. Right? So we combine the like terms and to solve it, so that would be 4x plus 2x plus 12 equals x minus 5, right? Now take a look. When we try to resolve the problems, then we realize there are some restrictions, right? So don't forget about that. That means when we try to solve it, x equals what? Some numbers except what? We cannot use. Look at the denominators, right? We cannot use -6 and 5. Is that right? So then we have what? 6x plus 12 equals x minus 5. Then you minus x here. So what do we have? 5x plus 12 equals what? -5, right? Then you minus 12 on each side, right? Then what do we have? We have 5x equals -17. And what's your x? X would be what? Negative divided by 5. So that would be your answer. Right? Can we circle the answer? Yes, because we know x equals what? Some numbers except what kind of numbers we cannot use? -6 and 5, right? So if you do everything right, then you know you can circle the answer by checking against the restrictions. Right? Let's look at the next one on your page 30. Number 5. So how should we start? Make single fraction on each side. So this one is 2x, x minus 4. This one will be what? With x minus 4, right? Then same fraction, so I mean same denominator. So this one you have to multiply x minus 4 on the top, right? Then we will combine them. We have 2x, x minus 4 equals what? X minus 4 here would be 8 plus x minus 4. So that would be what? X minus plus 4 now, right? Just simplify it. Okay? Become a single fraction. Then don't cancel them out, right? Because that's a prime, you keep them that way. You don't cancel out part of it. So now we have same denominators. We can just ignore it. Then write a what? 2x. You have what? Linear equations. At the same time, when we cancel out, we try to find the answer. Make sure you write the restrictions. So x equals what? Some numbers, except which one we cannot use right now is just 4, right? So you can check against your restrictions. Now that's minus x, so x is 4. So can we use 4? We know you cannot. So this one means what? It's extraneous, extra one. So, but you still have to answer the question. What kind of x you can have for the solution, right? You can say no solution, or you can say it doesn't exist. Either one would be fine. right? Think about it. What are we doing? Solving rational equations. So that would be your approach, one of the approaches you can use. Just to make each side a single fraction, right? Then you can eliminate the denominator with the restrictions noted, right? Then you solve either linear equation or quadratic equations. Look at the next one. We have x plus 14x minus 2 equals 7x over x minus 2 plus 1, right? So is this a prime? Yes, right? So we want to make a single fraction on each side. So use 1 as the denominators for those. Then what's your LCD? That would be your LCD, right? And oops, right? When we solve it, eventually we want to say the restrictions x equals some numbers except what you cannot use 2 for this case, right? So this one, it was 1, so you need to multiply by x minus 2 on both, right? So that's extra. Then you multiply by x minus 2. Then this one is 14. This one is 7x. And this one you multiply both numerator and denominator by x minus 2, right? So we write it in what? Prime forms. Then we write it in LCD forms as well. Then we make a single fraction on both sides. So that will be x squared minus 2x, right? Combine the numerators, right? So that will be 7x plus x minus 2, right? Then they have same denominators, and you can eliminate it with what? Restrictions noted, right? So what kind of equations we have now? So that would be what? ax minus 2. Quadratic equation, not in a standard form. So we write in a standard form, one side is the x's, another side is 0, right? So we can solve it. X plus 2, right? Cancel all those. So we have what? X squared minus 10x plus 16 equals 0. A quadratic equation. And trinomial. How do we solve a quadratic equation? By factoring them, right? So that would be two numbers. One is a minus 8, one is minus 2. Is that right? Multiply together, positive 16. Added together would be negative 10. So this one is x minus 8 is 0, or x minus 2 is 0. So this one is x equals 8. This one is x equals 2. Can I circle the answer? Let's take a look. We have this restriction, right? So x equals 8 is fine. Can we use 2? No, because that's extraneous. So for this case, you have one answer. For this case, you don't have any answer. right? So what do we do on this section? Solving rational equations, right? So that would be on the section 8.6, and we finished page 30.